Good morning, everybody. How you doing?
Good, thank you.
Yeah, everybody awake? No? No. We'll see if we can change that a little bit. Wake you up. You got some coffee out there. Congratulations on saying my last name. I tell everybody my last name allows me to take the handicapped parking space wherever I go. I mean, just living with this nomenclature, Maverick Ennis. What we're going to do this morning for the next hour is I'm going to try to talk about, as the title says, streaming media, the basics. I'm probably going to concentrate on some network behaviors. We're going to talk a little bit about video compression. Let me ask you guys, what's your orientation? Is it you want to hear more about the sort of video production side of things or the networking side? Do you have a particular bias? Sort of where they come together. Perfect. Excellent. That's what I'm going to try to do. In an hour, it's a complicated subject. In an hour, we're going to try to cover a lot of material. So, hold on. So let's get started. Oh, and as we go through this, please interrupt, ask questions. Throw something at me. Just anything that you have. If you don't quite understand what I'm getting at, speak up. Right? We'll just go through it. So it's a pretty complicated world right now for so-called streaming media. So we have problems, I think, with the very definition of the term, and we're going to poke at that a little bit. What the heck that's all about? So you've heard about this thing called IPTV, where service providers, carriers, telcos are going to deliver residential consumer entertainment to your home, and they're going to do it using what's called IPTV. I'd submit that's actually streaming, after a sense. Any of you guys have digital cable TV? Yeah. Digital cable TV is a digital delivery of ones and zeros of compressed video in MPEG-2 format to an MPEG-2 decoder inside a set-top box in your home. That's streaming video. So a lot of you have streaming video, you just don't tend to call it that. So I think we have to broaden our definition of exactly what, again, what is streaming video or streaming media. It's obviously deployed, and it's what my company VBrick does a lot of, is deploying streaming video, one-way, two-way video inside the enterprise, and we're going to poke at that a little bit. Enterprise means a company, a business, an agency, a department. We'll look at some examples of that. Obviously, the World Wide Web. Most of the times when people talk about streaming video, the mental model that comes to mind is, oh, I get it. I'm going to go to my desktop, I'm going to open up a web browser of some sort, and I'm going to view some online video on the World Wide Web. That's what most people think about when they think about it, and that's just a small portion of what streaming media does. It's much bigger than that. So certainly the World Wide Web. Any of you guys involved in satellite transmission? In the sort of traditional days, conventional thinking, satellite is DVB. At the end of the day, it's only delivering video. It's sort of a television broadcast capability. Nowadays, what the satellites are doing is simply delivering ones and zeros, just delivering data. And video is a particular class of data that can be transmitted over any network. So we'll look a little bit about satellite. Wireless includes, your hotspot, 802.11, right? Traditional, you got an adapter in your PC, but also includes cellular. I got a little cellular modem in my laptop here, and I can send and receive video directly over the cellular network, right? Because of its data carrying capabilities. What about video conferencing? Is that streaming video? As we look at our definition, I think you'll discover that it is. It happens to be streaming video, happens to be two-way, happens to have low delay, and it has a particular level of control, right, which allows you to do two-way video with some level of control. So that's actually streaming video after a while. I personally have a bias against traditional video conferencing, H323, H320 sort of stuff. Prefer more modern technologies which deliver telepresence, two-way, MPEG-2 broadcast quality, but do it two-way. So that's also streaming video. So I would submit a broad definition of our term is streaming media eliminates the notion of time and distance for better communications. And at the end of the day, the only thing we're really looking to do is to provide superior human communications. I mean, we're all in the communications business. And Audio, video just provides a best way to do that. So that's really what we're seeking to do at the top level. Does that make sense? Is that fair? Okay. But here's the problem, guys. I see this in so many areas. When you're a hammer, the whole world looks like a nail. Right? Maybe you've heard that expression before. So if you're a video producer, if you're a video guy, and you agonize over the pixels, you agonize over the hue and the color, and you just spend hours and days just trying to get the nuance of that video just right, my gosh, to do anything that damages that is just alien to me. So, where these things come together is one of the things we want to talk about. So here's the video producer. Gee, I got a camera, video source, I run a piece of coax, I display it over here. I know how that works. So why doesn't streaming video behave just like a coax cable? Doggone it, it should. Well, okay. But obviously, streaming video involves the network. We're going to send video over IP, aren't we? We're going to hook up to the corporate network. We're going to hook up to the internet. And it's a whole different culture in IT. And they look at streaming video and they go, same sort of thing. Doggone it, how come streaming video doesn't behave just like email? So, in a sense, streaming video often doesn't satisfy anybody from a conventional thinking point of view. It's not like email, and it's not like a coax cable. It's really something different. So, again, make sense so far? I'm old enough to remember, by the way, back in, in the early 90s, say 92, 93, there was a department, maybe you guys remember this, in just about any building, any headquarters, any department, called the Telecom Group, and they ran the PBX, right? And they would argue with the FTS 2000 rates or Tariff 12 rates. They ran the PBX, and they'd use modems to hook up SNA out to cluster controllers from the IBM mainframes, and it was all modem based. You remember these days? In the network, in the organization, came these weird packet head guys. I mean, they drank Chablis and they wore sandals. They're all weird. And the telecom guys hated the LAN guys, these packet head guys. Well, you fast forward the tape, and what you find is that today you have an IT department, you have an MIS department, and they all sort of get along. Well, they used to hate each other, and now they sort of, that call went out, time has passed, and the sort of the Rodney King sense, can't we all just get along? And you have a converged department now. One of the things that I'm seeing certainly is the classic video producers and classic video guys in the AV department is increasingly getting integrated more in the IT sort of domain, and it's all converging into a single department, and people are getting along a lot better. I gave a session here a couple of years ago. I've been doing this for about 10 years now. And you can see the convergence happen. You can see more and more classical AV sort of people getting a lot more IP-centric, and the IP-centric folks getting a lot more involved with video and being more sensitive to that. So maybe you know this stuff, or maybe it's obvious to you. It's nice to have statistics. What are the most common uses of this technology of streaming video? At least in the corporate world. Here's a survey that was done a couple of quarters ago, and the magnitude of the survey changes because there's more and more deployment. But interestingly, the percentage stays about the same. So a real common use of this technology is executive presentations. So we're at government video. So let me give you some examples. Down at, I think, Montgomery Air Force Base, for example. Great example. At that Air Force Base, they closed the base theater. I mean, GIs now rent DVDs, right? So nobody goes to the theater, so save time, save money, whatever. They close the base theater. In the Air Force, there's a mandatory commander's call where all the troops have got to march in, and the commander has got to give them a briefing every month, and that's mandatory. So they had no place to put them anymore. Where do you put your entire organization to give them a briefing? So they deployed this technology, and they have live video on every desktop, and the commander can just give his briefing live, and everybody can tune in and just see it inside their network. So sort of a government example of an executive presentation. Obviously, employee training. branding and advertising. I don't have to read it to you, but the list goes on for the uses of this sort of technology. So let's define some goals, then we can get into some of the depth of the technology. Because you have some choices. So, if your goal is to send and view audio and video over an IP network, what do you need? Well, gee, I could do live audio and video and multimedia. I could do live. Now, I'll tell you, if you do live, you can always do non-live. If your choice is, no, I'm not going to do live, I'm only going to create some files and sort of stream the files, you can never do live. So I always encourage people to organize your thinking, organize your technology decisions to make sure you can do live. You don't have to do it, but if you organize it for live, you can always do non-live, but not the other way around. So I can do live video, I can stream files, I can create a file and I can stream them. I could do fake streaming, right? What's called progressive download. We're going to see that in some detail as we go on. I could put up a file on a server of some sort and allow people to download it to my computer and then view that file. And that's what podcasting is. Podcasting, for example, is not streaming. Podcasting has got nothing to do with streaming. Podcasting is exactly the same as downloading a Word document from a server, moving it to a little tiny computer, one that's this big, and then opening it up and viewing it. It just happens to be a video file. Pretty simple, really. Podcasting is just file download. So that's good. I can do that. Each one of these has its own advantage and disadvantage. But I think in a converged world, the important thing for you guys is to understand they're not mutually exclusive. You really don't want to choose just one of these. They all have a place, and they all can work together to provide a superior experience to somebody. So as we tee up what we're trying to do, here's a simple description, I think a powerful one, of what the world looks like, this content chain. So I get it. I need to create some content. Now that could be a camera like we have here aimed at some event, or it could be some other video source that I'm rendering on a computer. So I'm going to create some live video, text, graphics. It could be one way, two way. And then I need to deliver it. So I'm going to deliver that content over a network, maybe using rich media, but most certainly over an IP network. How many folks here know what ATM stands for, other than a cash machine? Okay. There was a day when ATM, asynchronous transfer mode, particularly in the government, particularly in DOD, was going to cure cancer and win the war, right? I mean, that was the big thing. And we've migrated almost universally to an IP-based network. So you can pretty much always presuppose the delivery mechanism is going to be IP. Then there's consumption. Well, what the heck is that? I want my audience to see this stuff. So what do I need? I need some sort of a decoder. Decoder could be a player on a desktop, could be a set-top box, could be something else, right? So these are the three elements that you need to worry about. Most of the drama, of course, is in the delivery and compatibility at the edges. Then some level of control over all of these elements so you know what the heck is going on. So I think that's a very useful model. And you have different vendors and different technologies in each one of these buckets, right? That's a good way to parse the problem in terms of a content chain. So let's get into it. So the first step in streaming video of any sort is to create some content. So how do I do that? Really simple. You have a video source. I have a little camera here. I have a video source. And the first thing that's going to happen is I'm going to digitize that video. If I digitize video, here you go, pop quiz for you. See if anybody gets it right. Approximately, what's the bit rate of uncompressed video? If I take analog video, NTSC video in, and I digitize it, in between this box that says digitize and compress, about what would that rate be? Any guesses? What is it? 22 megabytes. How about 270 megabits per second from a serial bit stream? That would be 8-bit sampling SDI. It's about 270 megabits serial bit stream, I think, is is another way of looking at it from a serial point of view. It actually could be less than that depending upon 8-bit sampling or 10-bit sampling. But generally we think of it as about 270 megabits. If you're interested in the math of exactly how that is, you can go to VBrick.com or VBrick.net. There's a whole bunch of white papers up there that sort of runs the math and shows you sample rates and so on and how you can arrive at that number. Point is, it's a big number. It's bigger than you can send on an Ethernet or on the network. It's just a really big number. So in order to send video sensibly over a network, you need to compress it. So the next step, after you've dealt with the input type, analog, S-video, composite, SDI, maybe even Firewire, after you have that, then you perhaps do some noise reduction and adjust the resolution. You're going to digitize it. You're going to compress it. So what are you going to compress it with? Oh, gee, there's a lot of proprietary stuff out there. There's a bunch of shareware. There's a bunch of stuff out there that I could use. So Truth in Advertising, I'm on the board of the MPEG-IF. And the MPEG, I was also on the board of the Internet Streaming Media Alliance. Both organizations promote multi-vendor open standards. And I think that's important, to have multi-vendor interoperability. So I would always encourage people to gravitate toward those sort of things. So MPEG-1 would be a choice. MPEG-2 might be a choice. Then you have MPEG-4 Part 2 and MPEG-4 Part 10. Then you have VC1, which is also called Windows Media. Windows Media has become a safe choice for compression and decompression. It's no longer a single vendor proprietary solution. Windows Media was submitted to SMPTE, and SMPTE has approved that codec, and it's called VC1. So it's a very safe open standard now. A few years ago I would have stood, in fact I did stand here and say, oh my God, don't do that because you'll be hijacked by a single vendor, right? Now that's no longer the case, and it's a very good choice. And we'll see more about that as we go on. Okay, so now I've compressed it, I got to deliver it, compressing it, I got a bunch of ones and zeros. I got to worry about file format, but more importantly, I got to worry about this thing called streaming protocols. So what streaming protocols are available? What am I going to use? Well, you have the audio and video format, and the network protocols are going to be RTP, real-time protocol, RTSP, real-time signaling protocol, HTTP, which you're familiar with. That's, you open up your web browser and type in www.vbrick.com. There's an HTTP ahead of it, which runs typically on port 80, so it gets through firewalls, so HTTP is a good thing. And or I'm going to send the stream via multicast. And we're going to poke at multicast at some detail today. So I'm going to choose a protocol appropriate for my needs. And then I'm going to send it over the network. Okay, well, I don't need to go through the detail, but obviously I simply do the reciprocal at the receiving end. I unpacketize it, I uncompress it, I undigitize it, and then I deliver it to some rendering vehicle. Rendering vehicle could be your computer screen, or it could be your TV, plasma, LCD, whatever. Right? That's pretty much it. Makes it seem pretty simple. Right? Makes sense, right? Pretty simple linear thread. Obviously, it gets a little bit more complicated. As I mentioned with video conferencing, here's another way to think about this. Well, Rich, if it's sufficiently low delay and I send it in one direction and I turn around and do the same thing in the other direction, don't I have two-way interactive TV? Don't I have video conferencing or telepresence? Yes, of course you do. Of course you do. Most people don't think about streaming video in terms of two-way because you're going to presuppose, oh, the delay is too high. Well, that's not necessarily true. As we're going to see, it may be true in certain cases when you're dealing with the public internet, and we're going to learn why. So great, so far we've been able to send some video over a network. We haven't figured out exactly how that works, but compressed it, we sent it over the network, and we have live video at the other end. Cool. Well, in addition to sending it live over the network, or maybe instead of sending it live over the network, I don't want to do that. What I want to do is I want to make a file. Now, streaming media, if you talk to most vendors here, and most people, your brain says, oh, yeah, I get it. I'm going to get some sort of computer. I'm going to run some sort of software on it. I'm going to have a video input, and my object is to make a file. There's lots of authoring tools that, output the video into a certain compressed format. So it's the same thing, though. You're going to digitize, you're going to compress, it's going to be packetized, and then put as a file on a disk. So pretty simple. That's how you make a file. But depending upon your choice for compression, you're going to have different results, both for the live stream and for the for the live stream in terms of bit rate, and the file in terms of file size and bandwidth required to subsequently deliver it, right, depending upon your choice for compression. So what are your choices? Well, you could choose MPEG-1. MPEG-1 was the first MPEG standard. It operates from about 1.5 megabits up to about 3 megabits, and it delivers 352 by 240 resolution, CIF, or 352 by 240 resolution. Good standard, but it's a bit dated and not too many people use it nowadays. The advantage of MPEG-1, always use the right tool for the job. The advantage of MPEG-1, there's a high degree of interoperability with it, and there's no royalties associated with it, right, from the patent holders of the technology. So MPEG-1 is always a good choice. Everybody here probably knows that you all use MPEG-2 every day. I mentioned your digital cable TV, that's MPEG-2. When you have a DVD, the shiny disc, the only thing on that disc is an MPEG-2 file. That's it. So DVD equals MPEG-2. They are the same thing, right? That's what is on a DVD. So when I say MPEG-2, you can get a notion of what quality to expect. Exactly the same thing. MPEG-2 operates from about 2.5, 3 megabits up to about 15 megabits. The sweet spot for MPEG-2 is in the 3 to 6 megabit range. Typically, people run MPEG-2 over their networks at 4 or 5 megabits. That's a common rate for MPEG-2. Okay. Then you have MPEG-4. MPEG-4 comes in two flavors. You have MPEG-4 Part 2, and this is what has the highest degree of interoperability today and is readily available from many vendors. So MPEG-4 Part 2 operates from, 20 kilobits up to about 2 megabits. It feels in the lower edge of really where MPEG-1 and MPEG-2 operate from a bandwidth point of view, right? So that's MPEG-4 Part 2. Then you have MPEG-4 Part 10, also called AVC, Advanced Video Codec, also called H.264. You're going to get a headache if you go research and talk to vendors about H.264. You're going to get one of these ice cream headache sort of things. It's just terrible. H.264, MPEG-4 Part 10, is an umbrella specification. Rich, can I, if I testify in front of the judge, or take the lie detector test, and I put on my data sheet that my product delivers H.264, but what it does is delivers 2 pixels by 4 pixels, 1 frame per day. Is it compliant with H.264? Yes. Yeah, you can do that. That's fully H2. That's within the realm of H.264. So it's just terribly insufficient for somebody to say H.264. And it's meaningless. It's such a large specification. You'll find the video conferencing guys saying, "Oh, this is H.264." Yeah, but it's not interoperable with anybody else, so you might as well do proprietary. What the heck's the point? You'll go to a broadcast show like NAB, and the IPTV guys promote H.264 as a broadcast standard. Great, and in many ways it very much is. It will be the heir apparent for MPEG-2. But I would suggest that until there is a high degree of compatibility, it's not the ideal choice for the things that we're dominantly talking about here. It will be in a year or two, right? So I'd say give it some time. It's also, to implement H.264 in a meaningful way, it's 5 times more expensive than any of the other choices today. It's very, very expensive if you're going to implement it in a way that you and I mean when we say H.264. Give me the same quality as MPEG-2, but at half the band rate. half the bandwidth. That's what people expect from H.264. Then you have VC1 or Windows Media. Well, VC1 and Windows Media is really about 60–70% of the quality of H.264, but only at about 50%, 40% of the processing required. So it's implementable today. It's a very, very practical standard. It scales from sort of 0 to HD resolutions. It's a wonderful standard, and obviously is very mature and has a great deal of compatibility. What about resolution and frame rate? Well, another notion for you here. How is this interesting so far? Are we doing okay? Okay. I just want to make sure that we're on the right track. Because we have all these moving pieces, and we have to get them all into your head before we can really frame up some of the issues that we want to address. So as I think about encoding video, what are the other things I need to worry about? Well, there's also a relationship. Obviously, there's a relationship between bandwidth and quality. Higher the speed, the higher the quality. Yep, got it. Well, what are the other moving pieces here? Well, the other moving pieces is a relationship between frame rate and resolution and quality, or and bandwidth. So, let me give you an example. If I take some video and I encode it, let's pick a number, 1 megabit, nice convenient number, 1 megabit. At 1 megabit encoding rate, I can produce higher quality video at 15 frames per second than I can at 30 frames per second. You can think about it as I have more time to make each frame better, right? That's sort of one way to think about it. And same thing with resolution. You know, at 1 megabit, will the quality of my video be higher or lower at 720 by 480 or 320 by 240? Well, 320 by 240 may give you higher quality because I have more. I don't have as much data to compress within the time allotted, right? So you have all these moving pieces to do this. So the first step in any of these projects, anytime you're going to deploy streaming media, is to define the problem you're trying to solve. All too often, I talk to video producers again, and they go, I want broadcast quality video. You know, give me DVD quality video. And okay, and how are you going to display it? Well, I'm going to display it in a window that's this big on the computer. Like, okay. But, so, let me show you side-by-side comparison. Here's video at 200K, 300K, 500K, 1 meg, 2 meg, 3 meg, 4 meg, you know, various resolutions. Go look at them, and they all look the same in a window that's this big, right? So if that's your goal, you know, choose the right resolution, the right technology. On the other hand, if I'm displaying that video on my computer screen here, but I also want to display it at high resolution on a 40 by 40 projector someplace, I sure as heck don't want to encode the lowest common denominator either. Right? So you need to, again, sort of define the problem you're trying to solve. Some other pointers on video encoding. Motion is difficult to encode. Well, what does that mean? Well, sure, that means that it is more difficult to encode video when the camera is moving, because every pixel is moving, or sports events is more difficult to encode. But that's not really why I put this up here. I put this up here because if the video is crummy, if there's sparkles and, you know, just artifacts in the video, from an encoder point of view, that's motion. So even if it's a still image that, you know, there's nothing changing, but there's all sorts of garbage in the video, that makes the encoder work hard because it can't determine whether, you know, this is something you want or not. So garbage in, garbage out. It's always best to have high quality video, well lit video into an encoder than not, right? Because the encoder says, I got to work hard to do that. Frame rates can be variable. The lighting really, really matters, but more often than not, production value doesn't matter. I give a webcast every week, sometimes several times a week. I do it from my office, all messy desk, you know, I mean, whatever's going on in my office, and people can tune in and I can communicate. I don't have a Hollywood set, right? You don't need that. So casual streaming is very common now. The lighting matters, but the production value doesn't. Sometimes the production value does matter if it's something that you're going to repurpose and use for some other purpose. But you don't have to always worry about production value. Great audio improves video quality. Huh? What does that mean? Test after test after survey after survey has been conducted. So, you know, the blind audience test, take a look at this. What do you think? And it's the same video. You know, but the audio so oh, that looks terrible, right? Then you do it again, same doggone video, but you know, real high bass, good high quality audio. Ladies and gentlemen, watch my video. Oh, that looks really good. You know, the human mind puts it together. So higher quality audio gives you higher quality video from a perception point of view. Another tidbit here, if you turn up the color saturation, the human eye has more cones than rods. So if you have higher saturated color, humans perceive it as higher quality video. May fail the vector scope test, but humans like it better and they'll perceive it as higher quality video. So always use the appropriate resolution. And you can use multiple bit rates to solve multiple problems. Okay, so let's move to this notion of I've got a video and I want to send a live stream over a network so you to tune it in. How does that work? Video comes into the encoder. It's going to make a packet. In that packet is the data that we need. It's going to send it over the IP network to a receiver, in this case, some player on a computer. Great. Well, you notice that the packets are delivered at a constant rate. They have to. I'm creating some video, I'm encoding it, compressing it, and that packet goes over the network. And the time between the arrival of the first packet and the second packet and the third packet is all about the same. There's no staccatic delivery, right? It's a very smooth sort of streaming delivery. That's the goal, and that's what you must do for live. That's the goal. What about if I take a video file? You know, I got a WMV file, and I'm going to stream it. So I'm going to do it the easy way. I'm just going to take this file, I'm going to put it on a web server. Not a streaming server. I'm going to put it on a web server. And then I'm going to point you to it on my website. What is that all about? Well, the World Wide Web doesn't necessarily, well, not necessarily, it really has no mechanism to ensure quality of service, to really make sure that packets arrive, you know, in a regular rate. But that's not what I'm trying to illustrate here. What I'm trying to illustrate here is this is a web server, guys. IP networking, the basis for IP networking, client-server model, is make sure you can deliver whatever the customer has asked for as quickly as possible. In other words, a web server or a file server says use all available bandwidth until the packet is delivered, until the file is delivered. Right? That's the notion for a file delivery system or a web server. So on my illustration here, I'm squirting out packets as fast as I can, and they're arriving at the client. Could be a Word document, right? In this case, it's a video file. So this isn't streaming. It's exactly the same thing you do for a document or any other item that you're downloading from a web server. The consumer looks at it and says, oh, video plays, it's streaming. Well, it's not. It's progressive download. Well, how does that work? Well, these packets are coming in from the server at a staccatic rate. You know, here's some, here's some, here's some. They're coming in as fast as you can. And they're filling up a buffer on the desktop, on the user's computer. And that buffer is just filling up. And when it gets to high enough point where I got enough data there, then the player can launch and start draining the buffer. Basically, it's like an FTP download. But, gee, rather than waiting until the entire file is here, I'll start emptying the buffer to the player now. So this is what's called progressive download. And progressive download is not really streaming. There's a lot of issues with progressive download. It's a good thing to do if you have one or two viewers of one or two files, but it uses an enormous amount of web capacity and bandwidth, so it's not a good thing to do for scale. I do it for, you know, appropriate use, but not for scale. Does that make sense? Any questions on progressive download so far? Okay. So that's the notion for progressive download. What about streaming? Well, I showed you the live encoder delivering packets at a very regulated rate. The idea of a streaming server is exactly the same thing as a live server. So I have a live encoder. I'm going to deliver packets to you at exactly the same rate that the video is encoded at. Okay, now I make a file. I'm going to put that file on a streaming server. What's the job of the streaming server? To deliver the packets to you at precisely the same rate they were encoded at. In other words, from a client's point of view, there's no difference between a live stream and a stored stream from the client's perspective. That buffering mechanism isn't necessarily mandatory. Okay? The other thing that happens here is because it's a stored file, I have the opportunity to do navigation. You know, you've seen this on a player. So I'll move my slider bar over to, you know, to the right someplace, and after a few moments, the video plays immediately to that point. That's because the client is talking to the server and say, hey, stop sending me that part of the file, send me this part of the file, and the server responds and does that. You can't do that with progressive download. You have to wait till the entire file is downloaded before you can do any sort of navigation. Right? So my advice is, for any project of any consequence, this is why you use streaming servers instead of file servers or web servers for delivery of files. Make sense? You look amazingly lifelike out there. Yes, sir?
Does VBrick sell progressive downloading?
Yes. It's not a product or a vendor issue. It's a technology issue. Question: does VBrick sell stuff, you know, encoders, whatever, that produce files? Yes. Can you take that file and put it on a web server, and if you did that, would it have progressive download? Yes. If you took that file and put it on a streaming server, would it therefore behave this way? Yes. But we don't have any technology that's like unique to progressive download versus unique. It's a, you know, high-level industry sort of thing. Thank you for the question. Hopefully I'm doing well in the sense I'm trying to be pretty vendor agnostic, right? Sort of think about it more as a you know, tutorial session. Yes, sir.
You're talking about a web server versus a streaming server.
Yes.
What's the difference between a web server
Money.
and a streaming server?
Question is, what's the difference between a web server and a streaming server? We know what a web server is, right? It's an Apache server, it's a Microsoft IaaS server, it's, you know, it's a web server, you know, sort of a one-each commodity web server. Example of, so we know what a web server is. Examples of streaming servers is Windows Media Server. VBrick sells several flavors of servers, and the servers are unique to the format that they support. So there's one server to support MPEG-2, MPEG-1, another server to support MPEG-4, another server to support Windows Media. There's some overlap, you know, between the servers, but they're just different software running on the hardware, right? It runs streaming server software. Does that answer the question? Yeah. You have a computer, a server, you know, a Dell 2850, 2950, you know, whatever. You have a computer, and it has some operating system, Linux, Microsoft, whatever. Okay, now I'm going to run application software on it. What application software am I going to run? I'm going to run streaming server software, or I'm going to run web server software. It's just as a matter of interest, you typically cannot run both on the same server. And the reason for that is because what most people are attempting to do is provide video that goes through firewalls. Right? We have a big issue. We're going to talk about that, going through firewalls. Well, in order to make sure you get through firewalls, your web pages are going to be delivered on port 80. Everybody opens up port 80. That's your, you know, web sort of port. What you want to do is stream video on the same port. Well, one server can't share the port and use port 80 for web pages and port 80 for streaming. So you end up with two boxes. But for a lot of reasons, that's a very sensible thing to do from a capacity point of view and a reliability point of view. So, okay, we've teed up a bunch of stuff. So what are some of the fundamental elements that you need for a solution? Great, we need some sources. The source consists of digitize, compress, packetize, so encoders and sources. Then we probably need a streaming server. The streaming server takes the storage, does the packetization, sends that out on the network. So maybe a streaming server, only for files. I don't need that for live. Then I probably need a web server, because the web server is going to deliver me a web page into which I've embedded a player, perhaps, to pull that content from either the live encoder, you know, or the streaming server. Then I have the viewing side. So what do I have with the viewers? Well, remember, we got the uncompress, unpacketize, uncompress, undigitize. That's what these devices have to do. So what does that consist of? Desktop player, Windows Media Player, QuickTime, VBrick sells players, right, for MPEG-1, MPEG-2, MPEG-4. But I could also have a set-top box, which is just a hardware implementation of exactly the same thing. I could have my cell phone. Right now, there's live video being broadcast wirelessly from the VBrick booth. I can view that on my cell phone. I can view that on my PDA, wireless. We mentioned the iPod and podcasting. We're going to look at that in a minute, and that's just file download. So those are sort of the elements that you would purchase or engage in order to deliver these sort of systems. So let's think about podcasting and think about file download versus streaming again for a second. So let me get this right. I got this live encoder, live appliance. I'm going to set it to 250 kilobits. Great. And I'm going to stream it out to people to view. Well, there's no storage at the receiving location. The receiver could be pretty lightweight. It doesn't have to have a hard disk, so to speak. Obviously, it needs something, right? But you get the idea. It's very nice because it means that I can protect my content. I don't have to worry so much about DRM, digital rights management, when I stream stuff, because I'm not asking anybody to keep a copy. I can take it off the server and you no longer have it. It's not true with progressive download. Progressive download, somebody could mouse click on the link and they could download the file. Streaming, you can't do that, right? So it's much easier to protect the content. The web server, is a best effort download, but it depends on what you're trying to do. Maybe you want people to download it. That's your intent. I want people to be able to take the media that I've created, download it to the laptops, and watch it on an airplane. Right? Watch it on their iPod. So if I download my file to my computer, iTunes is a vehicle that downloads files and it has a nice menu allowing you to download files. I can then copy that file to another device, such as an iPod. That's all podcasting is. It's just a file download, put it on a little tiny computer with a nice screen. That's all it is. Or I can do the same thing I do with live, but no storage, by delivering that over the network to a playback device. Real quick thing on podcasting. So podcasting doesn't support MPEG-1 or MPEG-2 or Windows Media, right? It's an Apple thing. It's open standard. It's a good thing. It's exclusively MPEG-4. Exclusively MPEG-4. So in a podcasting environment, I create a little thing called an RSS file. It's an XML file. I put that on a web server. That file simply describes where to download my MPEG-4 video file. That's what it does. Oh, let me go look at that. It says, go download it from that server over there. Cool. So my player gets it, says, okay, I got to go download it, goes to that server, downloads it, then copies it to your portable player. That's all podcasting is. If you send the video originally live, you can record it and archive it. You can view it video on demand off a video on demand server, but you can also choose to put it on a web server so that file can be downloaded, right, to a iPod or become portable. Okay, I'm going to run out of time. Very important topics on bandwidth. So, gosh, IT people in here versus video people? Any, IT people? Okay, at least one. Here's the deal, guys. You plug video into your network and suddenly the video doesn't work or something else in the network doesn't work. Really simple. Video does not break your network. It just simply doesn't. It's a fallacy, fantasy to think that it does. What it does do is that it certainly exposes weaknesses that a network already has. That's an important thing to keep in mind. I understand it may be, well, that's interesting, right? The operation was a success, but the patient died. But it's not a matter of the video breaking anything. So get that out of your head. Video is an excellent network citizenship. It's just another class of data, but it can expose flaws. And the IT staff will often claim, I don't have any flaws, right? So you get into a cultural problem sometimes there. Video is not a bandwidth hog. You have a Ethernet switch. It has a 100 meg Ethernet port on it, right? Just do the math. If I send 5 megabit video, that's precisely 5% of the capacity of that port. It's a trivial amount of bandwidth inside a network or inside a campus. Right? So it's not a bandwidth hog. Most people think about video being a bandwidth hog because they're thinking about it from a wide area perspective. So Montgomery Air Force Base, 20,000, I'm sorry, not, Montgomery, I'm not sure what the numbers is. But commonly, if I go to Iraq, there's a VBrick appliance, you know, in Camp Victory, for example. And troops come back from Iraq and they all talk about how they watch VBrick TV. You know, it could be any other vendor. It happens to be VBrick, but the point is, the troops in Iraq, the only way they can watch television is on their laptop. ABC, CBS, NBC, you know, CNN, whatever, AFN. And you can have thousands, and in fact there are thousands and thousands of people viewing TV off of one brick. How does that happen? It's because of multicast. Multicast is the most important technology for the distribution of video in a campus network. Here's how it works. The video source is sending packets to your network. I'm showing a Ethernet switch, a router with an Ethernet switch here. And it's just sending packets all the time. And the switch takes it and throws them away, puts them in the bit bucket. Well, that doesn't seem very useful. But importantly, it's only sending one stream of packets to the network. What happens is the client makes a request. It's called IGMP. Multicast equals IGMP. All right? IGMP version 2, in fact. Or it could be SSM, but IGMP. So the client makes a request of the network, not of the video equipment, of the network switch. The network switch says, aha! You want these packets? I'll start forwarding them to you. The next guy comes in and says, you know what? I want that stuff too. You mind sending it to me? The router says, sure, here you go. The next guy makes a request. No problem. The network then responds and sends those packets to that client as well. And off you go, and that's scalable to, you know, theoretically, an infinite amount of capacity. So you'll very commonly plug in one appliance, one encoder, and have, you know, 10,000, 20,000 people tune into your live video, MPEG-1, MPEG-2, broadcast quality, you know, MPEG-2. Multicast is a very, very good thing for the delivery of video inside an enterprise. What's the alternative? Unicast. And this is what most people think about. They think about Unicast and they say, well, the bandwidth hog. So rather than sending one packet to the network, I'm going to send a stream of packets to each individual user. Well, in my example here, that means I would need at least 1 megabit coming out of the encoder, right, into the network, instead of only 250K. You understand? So this is Unicast versus Multicast. They both have a place. Multicast is a really, really good thing. So I'm going to take an appliance, I'm going to put it on my desktop, I'm going to go to my hotel room, pay the $9.95, plug in something, you know, for internet access in the hotel room. How can I scale? How can I get video out to everybody? So here I am, I'm on the left-hand side here. I'm on the LAN, and I want people out on the public internet to be able to see my video. So they make a request, but I'm behind a firewall. I don't have an outside IP address. So when they make a request, it fails. They can't get through the firewall. And even if they could get through the firewall, do I have enough bandwidth to the wide area network to support hundreds and thousands of viewers? You know, I probably got a DSL or a T1 or something, so that's not going to work. So what do I do? Well, people inside my network can make the request. They're not behind a firewall. I can support all of them. We just looked at multicast. I could do it that way, or I could do it unicast inside. So for scale, for delivery outside, here's what you do. You put up what's called the reflector. The reflector receives a single stream from the appliance. That single stream from the appliance goes out to the reflector. The reflector's on a high bandwidth network outside the firewall. The appliance does what's called an authenticated push, HTTP push, sends it to that reflector. That reflector is then your source for all your video, and you can scale to infinite proportions. I'll give you an example. Anybody a UConn basketball fan here? You're old geeks like me. I'm not a, you know. UConn basketball fan. I'm from Connecticut, but you know, a lot of the guys in the office are pretty crazy about that stuff. But we put just an appliance at the UConn basketball game and sent out to a reflector, and 9,000 people tuned in, and we're streaming at 300K. 9,000 people at 300K, it's a lot of bandwidth. That's because it's sending out to the reflector. The reflector then is on a high bandwidth network and deliver it to everybody. So that's how you scale any sort of webcasting. It could be inside or outside the network. Yes, sir?
Now, how does that differ from the multicast, other than the fact that it's sent outside the firewall?
The multicast is not supported on the public internet. So, I'm going to be really clear. Multicast is not supported on the wild and woolly public internet. It's not supported on DREN. It's not supported on virtually any of the wide area network except for the Internet 2. And some government, you know, fiber networks can support multicast. It's different here. I mean, now with that said, it's different here because the VBrick is sending one stream to the reflector. The reflector is then unicasting it out. I guess in a sense it's very similar to the multicast model, but here the multicast protocol doesn't have to be supported. So from a logical point of view, the result is the same. So, I mean, again, if I'm inside a network and it supports multicast, that's the way to go. If I'm out on the public internet, which doesn't support multicast, you need an alternative, this is the way to go. So maybe that's the best way to sort of parse that. Taking that to the next level, so, okay, so I want to do a webcast from here. I understand I can, you know, multicast or unicast locally on my LAN. I understand I can send it up to a reflector. Now I understand people can tune into the reflector, but what if I put a reflector in each of my branch offices? I'm on a private network, right, not on the public internet. I'll put a reflector in each of my branch offices. Well, now everybody in the branch office can tune in without consuming too much wide area bandwidth. You understand what I'm saying? So a big problem. Ooh, I heard there's a webcast. I think I'll tune in. So I tune in and look at it. And the guy sitting next to me says, well, that sounds like a really good idea. I'll do that too. So I use 300 kilobit of inbound bandwidth from the public internet when I look at it. He says, let me do that. He brings in 300, K of inbound bandwidth. That's 600. And the next guy and the next guy. You have a finite amount of inbound bandwidth into your building. 3, 4, 6 people tune in. You've crushed your inbound bandwidth. So if you put a reflector in the remote location, everybody tunes into the reflector. Only one stream comes into the building. You can integrate multimedia into this very, very easily. VBrick is doing some demonstrations of this, so you can integrate live multimedia, PowerPoint, and so on, along with the video. And the delivery is pretty much the same. I mentioned mobile wireless. We're sending some video via wireless over a cellular network. You can also send it via Inmarsat. BGAN is a great tool, so you can virtually go anywhere and deliver this by plugging it into the network, as we've just learned. Send video if it's in the appropriate formats, not MPEG-1, it's not MPEG-2. It may be MPEG-4 for some phones, but it's Windows Media for a lot of phones. If you want to deliver the video to mobile devices, PDAs, you certainly do that as well. It's just another form of data. Okay, we're gonna close up here. I want to make sure I leave a few minutes for some questions. So when you construct a system, those are all the elements, and it's basically on an IP network. And I think what you should look for as you deploy these systems is always look for multi-vendor interoperability. I just hate the notion of a vendor, hijacking any customer, holding them hostage, right? If you go into a proprietary stuff will always be better. I mean, it depends on what you mean by better. It'll always iterate faster. That's always been true in technology, some proprietary thing. But proceed with caution. Multi-vendor interoperability is key, and it's not enough to say, is it MPEG-1, is it MPEG-2? You want to make sure it's multi-vendor interoperability. You need a fully distributed architecture. You want to make sure that you support live and optionally stored. If you're dominantly looking for stored, again, choose a technology and an architecture that will support live. The future is, I think Yogi Berra said it best. Some things are hard to predict, especially the future. So if you can set yourself up, from a technology point of view to accommodate live, that's a great place to start. You probably need conditional access and permissions. I can tune in and see the video, but you log in and you can't. So look for that. One-to-one, one-to-many, many-to-one. So, yeah, I want to do entertainment. But if I have an encoder remote location connected to the back door, that's security and monitoring, isn't it? So the integration of multiple applications into a single unified network is a really good thing. Network citizenship is vital. So the devices that you select that are going to connect to an IP network have to connect to an IP network well. Look for things like SNMP management. IT staff really likes this. Make sure the products don't burst, right, and have high reliability. Integration, scale from dial-up to broadband, and gosh, we are at Government Video. You have to support Section 508. All of your content has to support closed captioning. So if it's public closed captioning from public TV that you're distributing, that's one thing. It's another thing to be able to type in the closed captions yourself. That's a mandatory government requirement. It's called Section 508. You're not supposed to deploy this technology if you don't support closed captions or open captions, right? One or the other. Qualify the network. Here are the pitfalls. If your network is wax, string, and tin cans, you're probably not going to have a really good day deploying this technology. So step number one, qualify the network. Don't make every use an event. Big pitfall I see. We're going to do a stream. Oh, okay, let's plan 2 weeks in advance and, get the dry ice and the fireworks going. It's like, no, casual everyday use and fall into everyday use of it. Don't go for the lowest common denominator. I got one user is on a dial-up connection, so I'm going to build a network where all video is crappy just because there's one user on a dial-up connection, right? Don't go for the common denominator. Another common pitfall is not to use all the tools that are available. Multiple bitrate encoding. Talk to the vendors. Don't go for the common denominator. Avoid the proprietary technologies, and for gosh sakes, make sure you provide adequate training. Not only to the staff and the producers, but perhaps more importantly, what people always forget is training the users, the viewers, what to do if something goes wrong. If you'd like a copy of this, send me an email. I'll be happy to send you this material. And again, there's white papers on VBrick.com. I also run a website called VBrick.net. It's more of a sort of geeky technology site, so you'll find white papers and a bunch of cool things there. And there's a whole collection of freeware, software sort of stuff you'll find at videolive.com. And I'm always happy to take emails and help out anybody that I can. We probably have a few minutes for some quick questions. So let's see if there are any. How did I do? Did I cover? Cover?